The image behind me shows one of the greatest moments in English sporting history. I was only 14 at the time, but I still remember this moment clearly. For those of you that don't recognise it, this is the moment that Jonny Wilkinson kicked the drop goal that won England the World Cup final against Australia in 2003 with only 20 seconds remaining on the clock. But moments earlier, the match was hanging in the balance. With 2 minutes to go and the scores level, England had one final chance to win the match. They'd secured a line out here where the circle is, and they knew that they needed to get the ball down the pitch and into the centre of the pitch in order to give Jonny Wilkinson the best chance of scoring that drop goal. But what was the best way of getting from the line out to where they needed to be to score the goal? My name is Laurence Cowton, and I've been working with professional top-flight rugby team London Irish to see if we can use data science and machine learning to provide actionable insights that will allow coaches to develop tactics with a higher probability of success. This kind of analysis has been used frequently in American sports such as the NFL, but is yet to be fully utilised in the rugby world. The data I'm using comes from sports statistics company Opta, who provide location and timings of all the actions on the pitch across a range of sports. I've had access to the past 5 seasons worth of Premiership rugby games, and I've collated this into a single database containing over 1 million actions. To make this data accessible, I've developed an interactive web app that will allow the user to specify queries based on a number of fields and allow them to plot those actions on the pitch. So for example, here I'm showing all of the drop goals that have been attempted this season by all the teams and coloured it by those teams. We can also easily change that so that it can be coloured instead by whether they were successful or whether they missed. And as we can see, drop goals are a fairly rare occurrence in rugby, and successful ones rarer still. So where did England need to get to in order to score that drop goal? Well, as this heat map shows, showing all of the successful drop goals from all the past 5 seasons, you need to be right in front of the posts. And perhaps that's a little bit obvious. So we can also pull out insight that wouldn't be maybe so obvious using this app. And so here I'm showing the location of all of the missed tackles for a particular team in a particular season. And as we can see, there's a higher density of these missed tackles on the left-hand side of the plot. And if you're a coach developing tactics to play against this team, this might well influence the way that you would play. But this data gives us the opportunity to do more than simply visualize it. By extracting the appropriate features, I've developed an algorithm that will determine the predicted probability of a successful routine following a line-out. These routines are often pre-planned and practiced on the training field in the run-up to a game. So an example of a routine might be something like this. We have a line-out here with 5 people in it. The number 2 throws the ball in. The number 5 catches it, throws it to the number 9, who passes it out to number 10. The number 10 runs up the field as far as he can before being tackled. The ball is then passed out to the number 12, who again runs as far as they can before being tackled. And we can judge whether this is successful or not based on the relative position of the second tackle to an imaginary line that we draw across the pitch at the location of the line-out, known as the gain line. And here we can clearly see that the second tackle is beyond the gain line, so this is a successful routine. An alternative routine might look something like this. And in this situation, we can clearly see that the second tackle is behind the gain line. So this is an example of an unsuccessful routine. Now the features that I'm using in this model are things like the location of these 2 tackles across the pitch, the number of players that you put in the line-out, or the location of the line-out along the length of the pitch. And these features are then fed into a gradient boosting algorithm that takes a series of decision trees and allows them to learn sequentially from the previous decision tree's mistakes. So, how good is this model at predicting the probability of success? Well, here I'm plotting the estimated probability of making the gain line after 2 phases against the percentage success rate that we observe in a data set that this model hasn't seen before. And because all of these different routines are lying along this one-to-one line, that means we're doing a really good job of predicting the probability of success. And it's this kind of insight that will allow coaches to develop tactics and cherry-pick their routines to give them the highest probability of making ground down the pitch. We can also see how this might change depending on where you are on the pitch and the number of players that you put in your line-out. And if we go back to our famous match here, we can say that using this analysis based on Premiership rugby games, England had a probability of about 0.65 of making ground down the pitch after 2 plays. And it's hoped that this kind of analysis will give London Irish the edge in those crucial situations and allow them to have less situations like this and more situations like this. Thank you very much.